Hello everyone. In the last class, we have discussed about the topics that are physical change and chemical change. We have come to know about that. So today we'll be discussing some of the, you can say test also you can say, or you can say experiment, through which we can see how the chemical changes occur and what reactions occur in them. What are the outproducts? All these things we'll be discussing today in this class. So let us begin. So the first experiment or the test that we'll be discussing today is the magnesium ribbon test. Now magnesium ribbon is just like a simple ribbon that we have seen already in day-to-day life, but this ribbon is made up of magnesium. Now what to do in this test is that, first of all, let us see the diagram, and then I'll be explaining to you one by one the processes that is occurring in this test or the chemical reaction. So this is the diagram. So in the laboratory, what we need to do is, there is an experiment done in the laboratory actually. So what we need to do is, we should have this thing. This is called the Bunsen burner, or simply the burner you can say. And it is connected to a cylinder, you can say LPG cylinder. And then this thing, and this is called what? For holding the magnesium ribbon, because we have to light this magnesium ribbon, we have to heat it, we have to burn it, you can say. So for that purpose, what we need to do is, we'll be using, we cannot hold it with hand. It is very risky. At some point, it will burn our hand due to heat produced. So what we need to do is, we'll be holding it with the help of this thing called tongue. These are called tongs, or simply tongue. So it's like a clip-like thing, and then after holding this, we will be burning this magnesium ribbon. So as soon as it starts burning, heat and light will be produced. As we have discussed earlier in earlier class, yesterday's class, or in the earlier class you can say, that in a chemical reaction or in a chemical change, the heat and light is produced. So here also heat will be produced, obviously, also light will be produced, and it will burn with a brilliant white color, or you can say totally white color. Brilliant white, the color is called brilliant white. So it will burn with that kind of a color. And then as soon as it starts burning, it will also be turning into ashes. Just like we burn the wood, it turns to ash. Here also it will turn to ashes. It's a powdered ash. So for collecting that ash, what we'll do is that we'll be in the just below it, we'll be holding a petri dish or a watch glass. It's given watch glass, okay. Even petri dishes can be used. So here you have used the watch glass, and here the ash, the powdered ash, will fall on that watch glass. So we will collect that. Now this product which has been formed after burning of the magnesium ribbon, it has a particular name. And it is called what? It is called magnesium oxide. The chemical composition also will change, as well as totally the magnesium compound or the magnesium material, it will totally get converted into another material. So let us first see the reaction that occurs here. As we know, in a chemical reaction or in a chemical change, whatever we say, a new substance is always formed. So here also we got a new substance. Which is that new substance? That is magnesium oxide. From where we got? From the burning of the magnesium ribbon. So let us see the reaction without wasting time. So this is the reaction. Magnesium, when it burns, and burning process is nothing but it is oxygen. Burning will not occur without the presence of oxygen. So burning, this whole process, is nothing but is an oxidation process, or you can say oxygen is used here. So when magnesium reacts with oxygen, that means it is burning. Whenever oxygen is used, that means you have to understand it is a burning case. So whenever magnesium reacts with oxygen, we get magnesium oxide. Here it was Mg and oxygen is O2, so we get MgO, magnesium oxide. This is the chemical formula for magnesium oxide. Clear? Now what to do is that we will be further investigating on this magnesium oxide. What is this compound? We got a new compound, so we have to know its characteristics as well. So what we'll do is that, you can see in this picture, this much process we have already done. A, B, till C we have done. We have collected this magnesium powder or ashes. Now what we'll do is we have to find out the nature or the characteristics of this powder, whether it is acidic or basic in nature. So how to do that? What we'll do is that we'll prepare an aqueous solution. Aqueous solution means we'll mix it with water. Whenever the word aqueous is used, you have to understand that it is mixed with water. No other liquid but water. So we'll mix it with water. We'll stir it properly in this watch glass. We'll mix it with water and then make it a perfect solution. After making it a solution, how to check that solution is acidic or basic in nature? And as soon as it turns a solution, one more thing important to know, that as soon as we will mix it with water, it will again get converted to another compound or another material or another substance. It will not be remaining as magnesium oxide anymore. It will get converted to another compound, you can say. So leaving that apart for the time being, how to check that whether it is acidic or basic in nature? Just remember what we have learned in the earlier chapter in acid, bases and salts. What we have learned is that to check that we will use pH paper. So pH paper will use red and blue pH paper, or you can say litmus paper also, the same thing. pH paper means litmus paper. So that litmus paper will be dipping it in that solution. And what we will find is that it will not turn the blue litmus to any other color. Blue litmus will be remaining as it is. But when we dip in the red litmus paper, it will change its color to blue. So what we can know from this reaction is that the solution that has been formed, or the compound that has been formed, or you can say the aqueous solution of magnesium oxide, is basic in nature, since it turned red litmus paper to blue. So we'll be coming to that, all those. First let us see the chemical reaction. Magnesium oxide, if it reacts with water, it gives us magnesium hydroxide. So this is the name of the new compound formed from magnesium oxide. So see, you can see the changes that has been occurring, the chemical change that has been occurring. First it was magnesium ribbon, then it got converted into magnesium oxide on burning. Then again magnesium oxide, when we react with water, it gets converted to another compound named magnesium hydroxide. This is the chemical formula, MgOH2. Clear? So what inferences did we get from this whole magnesium ribbon test? Let us see. First of all, we got a new substance, magnesium oxide, which was formed due to burning of magnesium. The next thing that we got is another new substance we got when magnesium, that is called magnesium hydroxide. From where we got that? From mixing magnesium oxide and water. So two substances we got. First we got magnesium oxide and another we got magnesium hydroxide. Clear? As well as we came to know that magnesium hydroxide is a base. It is basic in nature. How we came to know that? By testing with the help of a litmus paper. So red litmus turned into blue. So we are confirmed that it is basic in nature. Clear? Now moving on to our next test, that is reaction of copper sulphate with iron. Copper sulphate, let me say, it is a type of a salt. Just like we have sodium chloride, that is the common salt that we eat. So copper sulphate is also a kind of a salt. But we cannot eat that. Except sodium chloride, which we eat, other salts which are available in the nature are not eatable. It might be poisonous for us. So how this copper sulphate will now react with iron? Let us see. So this is the chemical reaction that has been occurring. So I'll be explaining this now. How does it happen? So first of all, what we'll do is that we'll take some copper sulfate solution, salt, and then we'll mix it with dilute sulfuric acid. Because copper sulfate is a salt, so we have to mix it and make it an aqueous solution or a liquid solution, you can say. So in order to do that, we have to add some liquid to it. And what liquid we'll be using here? We'll be using here a dilute sulfuric acid, not very concentrated, dilute. Then we'll mix it thoroughly, or we can say we'll keep it for an hour or two, and then it will get converted into this bluish color, light bluish color copper sulfate solution. Then what we'll do is that we will put inside this test tube where you have placed this copper sulfate solution. We'll put a new iron nail, totally new, not an old one or a rusted one, a totally new iron nail. Then after placing this iron nail inside it, we'll keep it as it is for half an hour. Then what we will see that this blue color or the light blue color solution of the copper sulfate will get converted into this greenish color, light greenish color, as well as this iron nail, which was before colorless, it has turned to reddish brown. So why did this happen? Let us see the reaction. Copper sulfate, that is CuSO4, when it reacts with iron, it gives us iron sulfate, that is FeSO4 plus copper, that is Cu. So what can we find out? What inferences can we find out from this reaction? We can find out that the change of the color of the solution, why there is a change of the color, first thing that will strike in our mind, that change in the color is due to the formation of iron sulfate. Yes, before it was copper sulfate, now the solution has turned into a different kind of a solution. It is called now iron sulfate, and that is a totally new substance. Next thing what we found out is that this brown color, why this brown color has occurred in the nail? It was before colorless, so why it has turned to brownish color, reddish brown? It is because of the copper that has been deposited on it. So two things we got: this color change because of the formation of this iron sulfate, and why this reddish brown color of the nail? Because of copper deposition. So this reaction has also another name. It is called a displacement reaction, or although it is not given in your book, you will learn all these reactions in your higher classes. But for the time being, just you know that the name of this reaction is called displacement reaction. What has been displaced here is this. You can see in this reaction, copper sulfate, when it reacts with iron displaces this copper from this copper sulfate solution. You can see iron is displaced, and now in place of copper it is iron, so it has turned to iron sulfate, and this copper is removed from it. It has been displaced, so it is also called a displacement reaction. Clear? So I hope you have understood these two reactions very well. That is a reaction of magnesium ribbon and the formation of different compounds from it, as well as the reaction of copper sulfate with iron. So these are very interesting reactions, or you can say chemical changes, that you can see or you can try out in your laboratory, and you can see for yourself how in a chemical change new substances are formed, new compounds are formed, new solutions are formed when it reacts with another compound or substance, and its properties, its characteristics, its nature also totally changes. So you can again go back to your textbook and see for yourself, understand the matter again. The concept I have already given to you, why it happens. So that's it then. Thank you and have a nice day.